Let us talk about the problem where these are the given. The reactants are hydroiodic acid and lithium hydroxide. So it's an acid-base reaction, a neutralization reaction. And if it is neutralization, it produces heat. You are given the calorimeter constant, the volume, the initial temperature, volume of the acid, volume of base, and initial temperature, and the final temperature after mixing. So, take note, tumaas yung temperature. Initial is 23, 23. Tumaas. So, it is an exothermic reaction. Now, punta muna tayo sa calorimeter. Yung simpleng setup, like sa laboratory, it consists of a coffee cup, which is made of styrofoam cup. And then this is where, because sa styrofoam, hindi naman masyadong nag-release ng heat yung styrofoam. Pero meron pa rin heat na na-absorb yung styrofoam. But in this case, sinisimplify, it is assumed na negligible yung heat na na-absorb ng styrofoam. So, ang kino-consider kapag ganito lang ang setup is the heat absorbed by the mass of the reaction mixture. Sa totoong calorimeter, binibigay yung calorimeter constant dito. So, ibig sabihin, itong problem na to made use of a real calorimeter kasi na-establish yung calorimeter constant. So, this is the reaction. 1:1 yung ratio. 1 mole of hydroiodic acid and 1 mole of lithium hydroxide to form 1 mole of water, and the other product is the salt lithium iodide. Okay, so between the reactants HI and lithium hydroxide, ito yung given. Okay? Molar concentration 2.03, ito 2.13. Volume 95.0, 95.5. So, if we want to get the millimole of this reactant, we can compute molarity and volume in ml. Likewise, so if we do that, we obtain 192.85 millimoles of HI, and sa lithium hydroxide naman, 203.415. So, alin ngayon ang limiting reagent? Compare this and this. Saan ang mas konti? Siyempre, ito. So, HI is the limiting reagent. So, the limiting value for the millimole is 192.85, or kung i-convert yan sa mole divided by 1,000 will give you 0.19285 mole. Okay, punta tayo doon sa heat. Heat of reaction is mass times specific heat times the change in temperature. Now, in this case, hindi lang mass of the reaction mixture ang naka-absorb ng heat, meron din yung sa calorimeter. So, this is the mass, this is the heat absorbed by the mass of the reaction mixture plus the heat that was absorbed by the calorimeter. Again, delta T, final temperature minus initial temperature is 13.4 yung delta T. Okay, so the mass of the reaction mixture will be the sum of the volume. Yung isang reactant is 95, the other is 95.5. We add them together, then we multiply by density. So we assume that the density of water is 1 gram per ml so that we can cancel out ml at magiging gram na to since mass ang pinag-usapan. We multiply this by C. Okay, so the specific heat. Okay, C is the specific heat. 4.18 joules per gram degrees centigrade. Then we multiply this by the delta T, which is 13.4. So this is the heat absorbed by the reaction mixture. And this is the heat absorbed by the calorimeter. So the calorimeter constant, 14.6, times the delta T, which is 13.4. Together, we will have this value. And since negative, so yung final answer mo will be a negative value. Pero yung delta H is Q over mole, the amount of mole that reacted. So, ito yung limiting reagent. So, we consider the mole of limiting reagent since yung excess reagent hindi naman na magre-react. So, yung limiting reagent lang ang i-consider natin. So, the Q that we obtain from here over mole of limiting reagent will give you this value. So, negative meaning it's exothermic or heat releasing. Negative 97.82 kilojoule per mole. Dito pala, kinonvert ko pa pala dito yung joule to kilojoule by dividing it by 1,000.